Okay, I would like to welcome you on my today's report on burden and instrument transformer faults. It sounds a little bit boring, but at the end we will see a proper solution where we can solve all the questions for this topic. Yeah, you know, all in Germany we are dependent on the PTB for billing measurements. We only can use inductive current transformers and inductive voltage transformers. So these are the conventional instrument transformers, as Michael told you. And yeah, this is a typical medium voltage current transformer. The primary current goes in through the copper, and here we can see the secondary cores. This is the measurement core, and even bigger the protection core, because you're measuring transients and so on. And you can see here the plastic housing for yeah, low voltage copper bus bars. And yeah, that's the inductive current transformer. And this is the electrical equivalent circuit diagram. And for the solution for the different burdens and the faults, we need to understand this electrical equivalent circuit. And yeah, it's not so complicated. We have here at the beginning the magnetic coupling, where the primary current goes in, and you get the secondary current. And of course you need a little bit of current for a little bit of power for magnetizing the core. And you have a fixed copper winding, and the secondary current goes through this impedance, and you have, of course, a voltage drop over this impedance. And one interesting thing is that the burden of the measurement device is influencing the voltage drop over the core. And so the voltage drop over the core defines the magnetic working point of the current transformer. And so we have to fulfill Michael's wishes, where we have to measure from 0 to 150, 200% of the rated current. And because of the core, we have a non-linear device. And yeah, we will see how to solve this problem. And yeah, of course, if you change your measuring device, you have another burden, and then you get another voltage, and then you're taking another working point for your current transformer. And of course, the current is going, for example, from 0 to 5 amps. Yeah, here we can see these are magnetic curves of the core material, and we can see here non-linear effects. And of course, the magnetization current of the core is affecting the amplitude and the phase error. So we have maybe some problems. If we have a high dynamic range, we have to go from 0 to something like that. So we have nonlinear parts of the error curve. And yeah, this effects we can see in the accuracy classes of the international IEC standards. Here we call it error trumpets. And here we can see that the amplitude error can be even higher than in the range of 80 or 100% of rated current. And okay, we know that the S classes are very accurate because they go down to 1%, but we have still here something like a trumpet. Okay, here in Germany we have some additional standard burdens for billing measurements from the PTB. And okay, for the international standard we have, of course, nearly the same. And if there is 5 VA on the rating plate of the current transformer, the instrument transformer manufacturer measures the accuracy class with the quarter burden and the full burden. Here we can see the quarter burden and the full burden is measured. And this is looking like this. We have here the amplitude error of current transformers. of this current transformer, and we have 5 VA as rated burden. And we can see here, this is the error curve perfectly in the class 0.5S. And if we take the quarter burden, which is measured by the instrument transformer manufacturer as well, we can see here, this is the purple line. And between these two lines, you have to be with your conducting lines and your energy meter. Because if you are outside this range, there could be an overburdening. And of course, if you're overburdening the current transformer, it can be out of class. And with smaller burdens, you can be out of class as well. And remember, if you take very low burdens, then you are always in the positive part of the amplitude error. So you are billing more current that is online, on the bus bar. You can earn a lot of money if you take less burdens. Yeah, phase error. We have also the phase error, and we have here the error trumpet as well, and these are typical values for a current transformer as well. And for class 0.S, we are dealing with something like 10 minutes to 30 minutes. And this has also an impact on the energy measurement. If we have a perfect system with sinusoidal waveforms, 10 minutes is only affecting the energy measurement with 0.00042%, which is nearly nothing, very accurate. But if you have a power factor 0.9, and here you can see it, but still sinusoidal waveforms, 10 minutes or 30 minutes of phase displacement is generating 0.12 or 0.36% error in the energy measurement. And in the end, we have nonlinear loads on customer side, and always in most cases they have bridge rectifiers, and their pulse peaks are taken from the grid because of the capacitance, and you can always see a voltage drop in the peaks of the voltage, the grid voltage. And if you take something like this and you are calculating the percentage error in energy measurement, you can get this non-sinusoidal waveform is increasing the percentage error in energy management as well. So we can state it that the amplitude error and the phase displacement should be very low to have accurate measurements. So looking at the inductive voltage transformer, in Germany we are dependent on the PTB, and that means we have to use it. We cannot use sensors or something like that in the medium voltage area. And of course, you can see here the core, as Michael shown you as well. And the customer is now ordering a voltage transformer for billing issues rated with 20 VA class 0.5. And the digital billing meters have always high impedances on their input. And here we can see, for example, 1 mega ohm, which means that we have only 0.0034 volt amps. And the same as a current transformer, the instrument transformer manufacturer has only to prove 100% burden and the quarter burden, 25%. And we have to be in this area. And you have to be in this area as well. And in worst case, you take this digital meter and you have only 0.0034 VA. You are very near the zero burden. And in the worst case, you are out of class 0.5. And now we take very accurate CTs and VTs in medium voltage, and we calculate only a 0.1% amplitude error and a 0.1 amplitude error for the VT. And we take in account 0.2 euro cent per kilowatt hour, and we take a lifetime of 20 years. And then we are generating in the billing system a difference of 1.5 million euros over 20 years. And now think of underburdening, classes of 0.5, and the phase displacement. What we need in future is very accurate devices, low cost, of course. And there we have to compensate all the instrument transformer ratio errors, and we have to compensate the voltage, the amplitude errors for the voltage transformer. And how we can do it? We can take these intelligent devices like CT Analyzer or Votano 100, and we can now measure our input impedance for the current transformer. For example, you get here the impedance 0.01 ohm with power factor 1. We got it. And now we can do billing 4.0. This is called 4.0 because now the current transformer is speaking with the energy meter. And now we can go to the manufacturing, and we can take Votano 100 and the CT analyzer, and we can prove our instrument transformers, and we get the whole electrical equivalent circuit diagram. We can call it digital twins. We can calculate the error curves with this circuit diagrams for every burden. So in the field, you can say, hey, you're using this energy meter, and with conducting cables, you get the special burden, or you can measure the burdens, and you can take your tablet, taking this burdens to the cloud, and where you can calculate the special correction factors for this specific burden. And then you can come back with a table with correction factors for CT and VTs, and then put it into the energy meter. You need, of course, a proper firmware, and then you can compensate all errors of these devices, and you have a proper measurement class 0. Yeah, thanks for your attention.
Thank you very much for this interesting presentation. And also nice to see when Omicron products in action. We have already got a question to you. It's regarding the influence of the non-linear loads. Does it affect both CTs and VTs or only VTs? So that means, does this affect what's causing the building issue, what you talked about?
Yeah, okay, we have a very good behavior for traditional current transformers, I think up to 10 kilohertz. But if you have very high THDs with 100% or 120%, then you can get some problems because you get very high amplitudes at high frequencies. But in general, CTs are very good to transform higher frequencies. As Michael said, we have some problems with VTs where we have some resonances coming from 2 kilohertz onwards. And of course, but for the current transformer, it is more important because for voltage transformers, you have only THDs from 0 to 8%. So in the EN 50160, in the power quality standard, you're in Europe, we have to fulfill this standard for product quality, and that's why we have to be don't hit the 8%. And so it is more important that you have a very accurate current transformer for higher frequencies. And of course, if you want to do very accurate measurements, you have to take special core materials and so on. But in general, current transformers are transferring very good harmonics.
Okay, because you also mentioned the compensation values, what you can use for doing this billing. And this is something which should be part in future in the standard, or is this something which can be done by the operator by themselves?
At the moment, we don't have spoken with the PTB already in Germany, but we can see that in medium voltage and high voltage, there are already some energy meters from Landis and Gyr with including correction factors. And okay, what we are using is a table of correction factors. And in my opinion, there could be no problem. Of course, you have to take the meter and you have to check if the firmware is okay with the compensation correction factors. But in fact, you have to talk to your PTB and afterwards, yeah, you have, I think there are no problems, but we haven't done it yet. I only have talked to Felix Feustel already, and there are some interested guys from the metering side, but yeah, of course, this is a traditional market and it takes time.
Okay, thank you very much for your contribution.
Yeah, thanks a lot.